So this is a classified topic 2, classified. First 43 pages actually I have discussed with different groups. So I will begin with 44 onward. And it's already there on the Google Classroom, these exercises. So you can also do practice. So we'll begin with 44. You can also use a screen annotation. You can annotate on the screen to answer these questions, and I expect active participation from everyone. You can also use your mic or a chat to answer. So in this question, page number 44, a magnesium react with a bromine to form magnesium bromide. So magnesium bromide is a compound which is formed. Magnesium and bromide is an ionic compound. Draw a diagram to show the formula of a compound and the charges of the ions and arrangement of only outer electrons around the negative ion, and the distribution of a bromide is 2, 8, 18, and 7. So first thing, in a magnesium bromide, we should understand what should be the formula for magnesium bromide. The magnesium belongs to group 2. So the group 2 has a charge of 2 plus. And a bromine belongs to group 7. So bromine will have a charge of minus. So when we cross multiply, the formula for magnesium bromide will be MgBr2. So MgBr2, so we have to draw one magnesium and two bromide. So when we draw one magnesium is there, we just need the last shell. So last shell, because the magnesium lost the electron, like the configuration of a magnesium is what? It is 282. So last shell magnesium, the metal has a tendency to lose all the valence shell electrons. So now this will be the last shell for magnesium. So this will be the last shell for a magnesium. So in the last shell of a magnesium, we'll have the 8 electron because it lost 2 of them. And the charge of the magnesium, it should be in a square bracket, it is 2 plus. What about bromine? Bromine belongs to group 7. Each bromine take 1. So 7 electrons belongs to bromine, and they mention cross for magnesium and circle with the bromine. So 1, 2, 3, 4, 5, 6, 7 for bromine, and 1 it took. So this will be a bromide ion. And how many bromide ions are there? There should be 2 bromide ions. So I should draw twice, but because of the space, I just put a number 2 there. So one magnesium ion, which is 2 plus, and the 2 bromide ions. No, they said the outer shell for the same thing, because they mentioned charges on the ions and arrangement of outer around a negative ion and the electron. So for a negative ion, as well as even if for magnesium, you draw the inner shell 1 electron, that's also fine. No problem. So this is the structure of a magnesium bromide. Writing a charge is important, showing the correct sign like the symbols X and O, or a cross and circle. That is also important. The next part, in a lattice of a magnesium bromide, the ratio of a magnesium ion to bromide ion is 1:2. Explain the term lattice. How we define the term lattice? Lattice is a regular arrangement of oppositely charged ions. So lattice is a regular arrangement of the oppositely charged ions. But use the term regular arrangement and the oppositely charged ion. Like this is a correct, more appropriate answer. Explain why the ratio is 1:2. So what is the reason why the ratio is 1:2? Because each magnesium loses how many electron? 2 electron. And each bromide gains only 1 electron. So the answer for this one, you will say magnesium loses 2 electron and the bromide gains only 1 electron. That's why for each magnesium, there should be 2 bromide. So the ratio is 1:2. But it's of 1 mark. So we are not supposed to give a detailed explanation here. We will just mention magnesium loses 2 electron and the bromide gains 1 electron. That's why the ratio is 1:2. If it was a sodium chloride, the sodium loses 1 and the chloride gain 1. So in that case, the ratio will be 1:1. because it's about ionic compound, so you have to use the term loss or gain. I will show the structure of the answer as well, because after every question, the answers are also there. What you can use the term charges must be balanced based on the valency group 2 and group 7, 2 outer shell electron for magnesium and 7, or magnesium loses 2 and the bromide gain 1. So multiple reasonings are there which you can write to score these marks. The next part, the reaction between a magnesium and the bromine, is a redox reaction. When we say a redox reaction, both oxidation and reduction take place. Oxidation, remember from oil, oxidation is a loss, and reduction, remember from rig, reduction is a gain. So the reaction between a magnesium and a bromine is a redox. Magnesium is a dash agent. Look, in this case, the magnesium is losing 2 electrons and the bromine is gaining 1 electron. So we remember oxidation is a loss of electron. So this changes oxidation. And the reduction is a gain of electron because the bromine is gaining electron. The 2 bromide ion gain 2 electron. But for a substance which is losing electron, the substance which is losing electron, oxidation happened for that substance, and what we call that substance, we call that as a reducing agent. And the substance which is gaining electron, reduction happened for that, and we call that as an oxidizing agent. So magnesium is a not reduction agent, we use the term reducing agent because it has lost electron. So oxidation, the substance which oxidation happen is a reducing agent, and this will be there in our topic 6. Yeah, this is there in topic 6. We'll discuss this in topic 6 as well. Bromine has dash because it has. So what happened to a bromine? Because the bromine has gained electron, so bromine has reduced, and because it has gained electron. So that is what we have to write. And this will be there. That's our next topic. Like the next session, we'll discuss the oxidation and reduction. So that's our next topic to be will complete. But in chemistry, because the questions are not like all from the same topic, there are, as the topics are having a relation, so they do ask question from one chapter. Like maybe a question is there, may have one part from chapter 1, another part from chapter 3, another part from chapter 10. So this is a commonly happen in chemistry questions. So use your copy of the periodic table to help your answer predict the formula of each. Barium oxide. What will the formula for barium oxide? Barium belongs to group 2 and oxygen belongs to group 6. And in exam, you will have the periodic table. This will be there in exam. Group 2, barium oxide. So barium is here in a group 2 and oxygen is there in a group 6. So what about their valencies? Barium is Ba. Symbol for a barium is Ba. No, that's not correct. Because when we write the formula, it should always be in a simplest ratio. So barium is there, belongs to group 2, so it is 2 plus. And oxygen is there, belongs to group 6, so it's 2 minus. Because the group 1 valency is +1, group 2 is +2, group 3 +4, -4, -3, -2, -1, and 0. Then we simplify the valency, 2 and 2 can be simplified as 1 is 1, the ratio, then it will be BaO. So the correct formula for the barium oxide, it should be BaO. Then a boron oxide. What is the formula for boron oxide? Here is a boron group 3 element. And oxygen is group 6. What is the formula for boron oxide? Good. So it will be, because the valencies are not same and cannot be further simplified, so it will be B2O3. So for barium oxide, the formula was BaO. For boron oxide, it was B2O3. Give the formula for the ions. Sulfide ion. Sulfide means sulfur because IDE, no, iron. That's not correct. For iron, there must be a charge on it. This is not correct. Sulfide ion, they said. So again, you have to use the periodic table. The charge for the ion, this is sulfur. Sulfur belongs to group 6. So group 6, what should be the charge? So the charge will be 2 minus. That's a sulfide ion. And what about the germanium? This is germanium. The next shows sorry, gallium. Not germanium, gallium. So what about gallium? It is group 3. So it will be 3 plus. So that is what you have to write for a sulfide ion. So it will be sulfur with a charge 2 minus, gallium with a charge 3 plus. Then draw a diagram to show the arrangement of valence electron in one molecule of nitrogen trichloride. Nitrogen trichloride means nitrogen combined with 3 chlorine. Nitrogen belongs to group 5. Group 5 will share 3 electron. So nitrogen trichloride means nitrogen combined with 3 chlorine. You are supposed to use a diagram in which you are not supposed to draw the lines. You are supposed to show the sharing of electron between them. So nitrogen trichloride, circles you can draw at the last. First, you will show the electrons. When nitrogen share 1, chlorine share 1 from that side. Unshared electron on chlorine, as it belongs to group 7, there will be 6 unshared electron on each chlorine. And for nitrogen, 3 shared are there and 2 of them are unshared electron. So this is the electron arrangement. Then we draw the circle. Each circle should have 8 electron. So this is a circle for chlorine. This is also a circle for chlorine, and that's a circle for nitrogen. This is the structure of nitrogen trichloride. In exam, if you draw like this, you will lose the mark because you're supposed to show the valence electrons, the unshared and the shared electron when they ask to draw the diagram. And they already mention arrangement of valency electron. So your diagram is not showing the electrons, so that's why it's not correct. And cross for nitrogen and dot circle for the chlorine, that is already we did. The next part, the potassium and vanadium are elements in period 4. State 2 difference in their physical properties. This is related to the metal part, like the chapter metal, in which we discuss about the compare group 1 and the transition element. You will see the periodic table. The periodic table, we have this part of a periodic table. These are the transition elements or transition metals. So in metals topic, we'll discuss and we'll compare the group 1 elements, like these are the group 1 element with the transition element. I can state the property, but that is not the topic, we have not discussed. No, the physical property, both, this is not correct. Both of them, all metals are good conductor. Rate of conduction may vary between the metal, but all can conduct electricity. Yes, Abdullah.
So transition elements form color compounds, yeah?
Yeah, but you need a physical property. Physical property, group 1 usually are soft, transition metals are hard. This is one of the, when we compare the melting point, group 1 have low melting point, transition metals have high melting point, because that is about the physical property. Physical properties such as melting point, boiling point, stage, density, transition element have high density, group 1 have low density. These are physical. Chemical properties means how they react. Transition element can be catalyst, can speed up a reaction. Group 1 cannot be used as a catalyst. Transition element shows a colored compound or form colored compound. Group 1 does not form colored compound. Transition element shows a variable oxidation number or the charge, but group 1 have only single oxidation number. But as I mentioned, this will be there in topic metals. So we'll discuss there in the topic metals and the periodic table. So these are some questions from topic 2. Moving on to the next one. Okay. You have three elements are listed, particle A, B, C. What is an evidence particle A is an atom? How you know it's an atom? A substance atom does not have charge. So what is the reason why it's an atom? Because it has equal number
proton
of
and electrons.
good. So it has equal. I'm writing in short. It has equal number of proton and electron. But you will write the statement. They are all particles of the same element. How I can say they are all same element?
Same proton number.
Very good. They have the same proton because the proton number is the identity of the element. If the elements have the same proton, like different atoms have the same proton number, it means they are the same element. Particle B is a negative ion. Why particle B
More
is a negative?
more electrons than protons.
More electron than proton. Good. Why A and C are the isotopes?
Different neutron numbers, but same chemical
Then
properties as well as
no, no.
protons.
If you use the term proton number, different neutron number, then you should say same proton number. So you will say they have same protons
Yeah,
or
I
they have
said same
no need to refer a property. So they have the same number of proton and different number of neutron. That's why they are isotopes. That's a characteristic of an isotope. What is the electronic structure of A? Like how electrons are arranged in A? You have
285.
15. Good. 285. What is the valency of the element? What will the valency? 285. What will the valency of this?
Plus,
What will the valency? 5 electron in the
min
last shell. So it means it
minus
is
3.
good. It is group 5. So what is the valency of a group 5? Group 5 will be -3 or 3 minus, you can say. Is the element a metal or a non-metal? Group 5, metal or a non-metal?
Non-metal. Non-metal.
Non-metal, and reasoning is that because metal contains 3 or less than 3 electron in the outermost shell. It has, you will say it has more than 3 electron in the outermost shell. So this was the answer for. So it is a non-metal. Why we say it's a non-metal? Because it has 3 more electron in the outer shell. If it was a metal, it will have 3 or less than 3 electron in the outer shell. So this was exercise like the classified question from topic 2.